It's great to see a lot of friendly, familiar faces. It's nice to be at Connect. It's the first time I'm attending in person, also probably not the last, so it's nice to be here. I appreciate that it's really bad form to come to a conference and immediately talk about another conference. But if you really want to see how pervasive the ARM architecture is, you really don't have to look much further than Nuremberg in the spring, and we just had Embedded World, so it's top of mind. The range of new products on offer from ARM partners at Embedded World every year is incredible, and this year was no exception. There are some incredible demonstrations that we saw this year, product launches from a lot of ARM partners, from low power MCUs to Matter smart home enabled devices, and of course a huge amount of AI applications. And an incredible array of demo from robotic arms playing chess to new Windows and ARM products, and even a dive computer illustrated with a life-size mannequin of a diver, which I thought was particularly cool. In all of this, it's really important to both appreciate the breadth of the work that we do and where it lands in the industry, and also not lose sight of the real-world applications that we're driving with some of the innovations that we're talking about and discussing this week. This is a friend of mine. His name's Yannick. He lives in France. He's a welder. He spends a lot of time working on old cars, old yachts, and is often asked to do a lot of restoration work. A big part of that work involves welding two types of metals together. A lot of the things that he was working on in the past, these old boats and cars, they tended to be crafted with steel. Nowadays, we have hundreds of types of steel, and one of the most common problems that a welder can face is how to weld two types of metals together. Now, the choice of filler wire that a welder uses is actually one of the most crucial parts of welding. It's the heart of the fusion as you go from a solid state to a liquid and then back to a solid state again. To determine the filler wire that's needed in order to bring two different types of metals together, you have to put it into what's known as a Scheffler diagram. And you have to input various variables and constraints, such as the type of metals and the energy inputs that are required during welding, the cooling time, dilution for each welding procedure. And this used to take him hours. So at the start of a job, he would spend many hours looking at the different materials, putting them into this diagram, figuring out what that looks like in reality, and then going off and doing whatever he had to do. And we were sat in the bar the other week, and he told me that he found this incredible new thing. He said, "John, I found this really cool thing that's helping me save hours and hours and hours off what I'm doing. It's called ChatGPT." And he started going to jobs and using ChatGPT to express in natural language different constraints, problems he has to solve. And it spits out a reasonable result of, well, this should probably be the material that you use for a filler wire. He assures me that he checks the result after he goes off and consults ChatGPT to see exactly what he should be doing. But it's one really interesting example, and one that I would never have thought of, about the productivity gains that we can get from some of the work that's being driven in the conversations and the products that we're building together. And it's really easy to get lost in a larger narrative about how productivity gains we're going to see across an entire economy because of artificial intelligence, and it's easy to throw it off. And then you think of this example, and Yannick's gone from spending several hours at the start of a job looking at how to put something together, and now he spends 5 minutes tapping it in natural language and then gets a nice result at the end of it. Of course, as many of you would point out to me, if this is all formulaic. You could probably just build an application to do exactly the same thing. You don't need an LLM to solve this problem. That's true, but Yannick doesn't own a PC. He has no interest in owning a PC. He does own a phone, and he's more than capable of telling the phone through text or voice what he wants to do and then get the result given to him at the end of it. And the pervasiveness of that technology is really interesting in this example, because this is someone that would never be at the forefront of technology, but yet he's using LLMs every single day in the work that he's doing. So what are we doing at ARM? Well, In driving this capability down to the embedded edge, of course, you can address a far wider range of use cases on device, and you can address a lot of constraints that may exist. So driving this capability down to the device such that you don't need to have any active connectivity, for example. And as edge AI scales, silicon vendors as well are navigating this growing complexity in both system and software requirements, and of course an increasing demand for AI performance. At ARM, we have solutions ranging from Cortex-M all the way up to MPUs. And in the IoT space, we really focus on three areas. The first of which is Cortex-M, primarily with Helium. We have secure connectivity enabled through things such as ARM Trust Zone. And we also have our own range of MPUs. So we have the ARM Ethos U. And in Embedded World this year, we announced the latest version of the Ethos U, which is the Ethos U85. The Ethos U85 is our highest performance NPU to date. It's configurable up to 4 TOPS, which delivers a 4 times performance increase over the previous generation. It's also 20% more efficient in terms of energy consumption when compared to the Ethos U65. But more importantly, given the story I just told, in addition to CNN and RNN support, U85 also introduces support for transformer networks. And transformer models, of course, are models that are capable of learning context. And so they tend to be quite useful for applications such as text processing, which enable LLMs. And it would be really interesting to see how this might be used on device in the future, as Sergey was saying in the previous talk, without this having to go to the cloud and back in order to drive that capability. The Ethos family of NPUs has been licensed by more than 20 partners already. That's across the U55, U65, and now U85 as well. And we also work closely with software partners to enable functionality. So a lot of the names you can see here, but examples such as, indeed, Edge Impulse, Notor AI, who provide a model optimization solution, Plumerai, who provide a full AI stack for smart camera applications, and partners as well like Quixo, who build ML solutions, consuming data from ultra low power environments all the way down to a Cortex-M0. In IoT, we also bring together our IP into subsystems in order to provide demonstrations of how the capability can be used, but also provide a reference implementation and reference examples to partners who may be looking to license the technology. With U85, we have a new Corstone reference design platform. That's the Corstone 320. It's our highest performing IoT reference design. We've paired it with Cortex-M85, which is our highest performance MCU with Helium vector extensions. And we also have a Mali C55 ISP in there, which makes it particularly useful for vision applications, low power vision applications such as voice, audio, general purpose AI as well, in addition to battery powered smart camera. Now, of course, we don't stop at the IP. We also provide reference applications and a whole set of software alongside the core IP that we provide. So we bring together the reference designs with software and tools both from ARM, but also from the ARM ecosystem. And we also bring together ARM prototyping platforms as well. So for example, the Corstone 320 is available on ARM virtual hardware. As part of the software and tools offering, of course, ARM provides development tools such as Kyle Studio, components that are provided in terms of CMSIS packs, and also reference implementations that we provide. We do a lot of work with RTOS vendors, and we actually provide reference implementations of both AWS FreeRTOS and Zephyr RTOS as well. And working as well with integrating with CSPs through those contributions to the common RTOSs. As I mentioned at the start, the range of use cases that we can see with this capability that we're offering is probably broader than we can imagine. In the IoT line of business, we tend to focus in a few areas, for example, smart home, smart city. But beyond silicon, the AI software ecosystem is also converging on ARM. I also mentioned some of the software ecosystem vendors we're working with. In addition to that, we're working with a set of AI frameworks as well. So we've provided specific optimizations for TensorFlow Lite and PyTorch. And of course, we have a broad range of silicon partners shipping this capability. Now, how does this all matter to everybody in this room? Well, as Sergey mentioned, in the IoT, many deployments they're complex distributed systems. We're not talking about a single endpoint. And there's a number of constraints that we should be aware of as we're building these systems. One of which is the need for heterogeneous systems. We have a diverse set of requirements and a lot of use cases that require specifically tuned hardware. It's really important to enable frictionless deployment, and for our customers, this tends to represent fastest time to market, whilst also eliminating any non-differentiating overheads. In other words, standardize where possible. And also enabling security at scale. So deploying more complex distributed systems, security is really important, and standardization of security capability across those devices is incredibly important when you have a different mix of roots of trust on the device, for example. The other thing that's really coming to the forefront now is an increased amount of regulation that we're seeing, and upcoming legislation. Here in Europe, we have the CRA, which is being defined by Brussels. The UK has a similar initiative, or a set of legislation rather, called PSTI. And this is something which is causing a lot of discussion amongst our customers and also different device vendors shipping this capability, because the reality is that if you're not compliant with this piece of legislation, you may not be able to ship your device into these markets. And so that legally enforceable security is really driving a conversation about standardization, consistency at scale, but also how these devices are secured in the field. Of course, the technology factors don't go away. And so industry requirements, one of which we see in IoT a lot, is the need for long-term support in various industries, such as industrial automation and robotics, for example. It's not uncommon to see 10, 15-year software support required in order to ship into these markets. And with all that being said, that's why it's really more important than ever to make sure that we're designing with best practice and interoperability in mind as well. And I want to talk about a couple of things that we're doing in order to enable that. One of the things we do from a security perspective is invest in initiatives such as PSA certified. And this upcoming legislation, in my opinion, makes things like PSA certified far more important than ever. It's incredibly complex for a device vendor somewhere else in the world to understand, go through legislation of what's required in Europe, what's required in North America, what's required in the UK, what's required in these different industries in terms of industry standards. And one of the key value propositions of PSA is really to reduce that burden on OEMs to demonstrate compliance with both that best practice, but also the legislation that's coming through. Vendors should not have to look through pieces of legislation, and they should not have to look through endless standards to determine whether they can ship into a market. If they can align with something like PSA certified and get 75% of the way, then that's a huge value to the market. It accelerates time to market, it accelerates consistency, and it also makes it a lot easier for these devices to be shipped in the field. Of course, all of that's completely pointless if developers can't make use of it, and so there's also a set of PSA certified APIs that we provide for use by developers. One of the contributions we've made over the last 12 months, for example, is a specific firmware update API that we're providing in line with PSA certified. One of the other things that we do is we continue to invest in programs like System Ready. And System Ready really exists to enable a consistent set of operating systems to boot across on platforms from embedded IoT devices to on-base service. I don't think I need to tell this room what System Ready is. I know there's already been a few sessions and talks on it so far in the conference. The momentum that we're seeing with System Ready has been really encouraging over the last few years. We have 14 silicon vendors that are System Ready certified, And across those 14 silicon vendors, we have 136 devices now system ready certified. And you'll see some IoT ones here, such as Arduino and Raspberry Pi, and a diverse set of operating systems and distributions that we're supporting as well. Now, I've spoken quite a lot about the need for continuously updating devices, making sure that they're continuously secure, making sure that we're aligning to regulation, enabling devices in the field to be kept up to date. But we still do this. So for every device that we look at ARM, we take these devices and we say, okay, we'll look at the firmware and we'll put it through our ACS, our Automated Compliance Suite for System Ready, test it against at least 2 distros, and then when we decide that it's compliant, we'll issue a certification. And each certification says, essentially, on this date for this piece of firmware, against these operating systems, this device is compliant. This, of course, is incredibly important. It's important that we have a process of doing this both through ARM and through third-party test labs to make sure that the devices that we see coming to us are indeed compliant with the specifications that we outline. But it's probably not enough. So about 12 months ago, we were sat down at another conference, I think it was, and we said, you know what, we should probably do something about this. We should probably help people to be continuously compliant and to bring together all of these different test suites that we're looking at. Not just ARM test suites, not just System Ready and PSA, but also different components as well, middleware components that we see coming from third parties, such as AWS and Bosch, for example. And we decided to create one lab with Linaro. And so ARM is a primary sponsor and indeed customer of OneLab. We're a supporter of the program. And OneLab brings together all of these test suites that I've talked about today. So it brings together the ACS from System Ready. It brings together security components that contributes with PSA, such as trusted firmware, for example. But it also brings together OS testing and components from AWS and Bosch. With those components, we can tell a full stack story. We're not just talking about the capability to get you to shell, we're talking about the capability to ship a product. And once you've shipped that product, you can also make sure that that product is kept continuously up to date and in a transparent way. Instead of having a static certificate where, for System Ready, for example, where we say, this is a piece of firmware that was available when we tested this device, you'll be able to access the firmware associated with that device through OneLab. And the same goes for the other components that we're addressing here as well. The reason we're doing this is really to bring all of this together to enable continuous integration and testing of the whole stack to keep products updated, maintained, and secure. With that, I think I'm going to hand over because I think that there's a panel discussion rolling into some of these topics. So I'm going to hand back over to the team.
Thank you, John.
Thank you.
Okay.